Hi, this is Shaylee, and this is my YouTube channel, AI Economics. I'm a professor of artificial intelligence, and I teach AI concepts decoded for a business lens. If you're interested in this kind of content, please do consider subscribing. Now to today's video. This is part of a sequence of videos that I am developing for developing generative AI applications for business managers. It's not just restricted to business managers. It's basically anyone who is non-technical. Now, the motivation for this particular sequence of videos developed when I saw a large number of YouTube tutorials which promised development of generative AI models, applications in 15 minutes for no code, low code, etc. Once I went through some of those tutorials, I realized that the whole entire process was a lot more complex and that there was a lot of stuff which was presumed to be known at the back end. This means that if you're a new person, a brand manager, say, starting out with some minimal knowledge of Python or coding, then chances are that even if you manage to follow along with the coding aspect, you will not be in a position to really understand how the application is structured and therefore how to create your own application, which is very process specific. Hence, I developed these sequence of videos. These videos begin at the beginning, where I start off with all the concepts which I think are absolutely essential. Some of these are covered at a very high level. And as I proceed along, we will start deep diving more and more into more technical aspects. In today's video, for example, we are going to be discussing word embeddings. Word embeddings are foundational to both the way large language models function, as well as being a very critical element in the development of retrieval augmented generation systems. Recall that in an earlier video I had mentioned that generative AI models have not been adopted as enthusiastically by corporates as expected because of the hallucination problem. This is the problem where the model tends to make up its own answers or wing it on its own knowledge without necessarily being accurate. There were various workarounds which have been developed. One of these is fine-tuning, which is both expensive and time-consuming. The second one, which is retrieval augmented generation, is far more popular and is in fact the approach that we will also be taking in our hands-on tutorials. But to understand RAG properly, you do need to understand the foundational concepts of how large language models function and also how a very critical component of which is word embeddings. So let's get to it. So let's get to understanding what exactly are word embeddings. So computers don't really understand words. Everything has to be converted to numbers to be machine readable. Word vectors come in here, solving this by representing each word as a standalone unique vector or list of numbers. And these numbers show the relationships of the words to other words. Then, using the principles of vector algebra, we find words with similar meanings are placed closer together in this space. For instance, king and queen would be closer in vector space than king and apple. It seems a no-brainer, but it actually is quite miraculous when it comes through in a deep learning model. So therefore, word embeddings allow us to capture the meaning and relationship among words. Each word's position in this space is learned from usage patterns in large volumes of text and is not predefined by any rules. Hence the need for a very large volume of textual data, training data, which is what people talk about when they talk about deep learning models and their voracious need for data. So what do word vectors look like? Words are mapped into a vector space where each word is represented by a vector of real numbers. I have pasted in this image, and this is basically what a word vector looks like. The beauty of representing words as vectors is that they lend themselves to various mathematical operations. For example, we can add and subtract vectors. But first things first, what is a vector? Geometrically, we can this picture defines what is a vector. It is a directed line segment whose length is the magnitude of the vector and the arrowhead indicates the direction. So it's basically a directed line segment which has magnitude and direction. We can also represent the vector in 2D Cartesian space, that is to say the x-axis and the y-axis, and this is our vector A. So that its tail is at the origin and the head of the vector will be at some point A1, A2. Now, vectors can also be represented numerically, as I just said. For example, we can have a row vector A and it is consisting of 1, 2, 3, 4, 5, 6 in square brackets. And we can have a column vector B. Now the dimensionality of a vector is the number of rows times the number of columns. In the case of vector A, we see that there is only one row, but there are 5 columns. So the dimensionality is 1 cross 5. Similarly, in the case of vector B, there are actually 5 rows, but only 1 column. So the dimensionality is 5 cross 1. Before plunging in further into word vectors, let's just try and get our head around the concept of vectors. They're not just some arcane mathematical concept. It is something which is very live and relates to real life. In real life, for example, vectors are used extensively in physics. For example, to represent force. Force has both magnitude, which is in newtons, and direction. More common examples are acceleration and velocity, both of which have magnitude and direction. Now, one important point to be noted is that we should not confuse vectors with unidimensional numbers, new quantities such as scalars. These are not vectors, as basically they can be represented by just one number. Examples of scalars are speed and distance, because over here it is not a direction, it is just a value or a number. On the other hand, vectors are shown in a 2D or 3D coordinate system as a directed arrow having both magnitude and direction. I hope you followed along in this video. It is a little technical, especially for the people who have left maths a long time back. However, I assure you that what you need to know is not the nitty-gritties, but just the overall concept. I'm pausing this video for the time being, and the next video picks up further on word vectors and word embeddings and how they are actually created.